Hello everyone and welcome to yet another daily challenge from Leetcode. So this challenge is set reservation manager. It says to design a system that manages the reservation state of n seats that are numbered from 1 to n. Implement the seat manager class. A seat manager, a constructor seat manager initializes a seat manager object that will manage n seats numbered from 1 to n. All seats are initially available. Okay. Int reserve fetches the smallest number unreserved seat, reserves it and returns its number. Void unreserved with integer seat number unreserves the seat with the given seat number. So we can check over here, it initializes this thing, reserves it. So 1 is reserved, 2 is reserved. When we call unreserved, 2 is popped out. Makes sense. So looking at the constraints, so it's 10 to power 5. So seat number is less than equal to n, which is obvious. For each call to reserve, it is guaranteed that there will be at least one unreserved seat for each call. Okay, to unreserve, it's guaranteed that seat number will be reserved, which should be the case. At most 10 to power 5 calls in the total will be made to reserve unreserve. Okay, oh, makes sense. It is pretty straightforward then. So while jumping into code, one thing we need to remember is we need to suggest the minimum, the least seat to reserve, and to unreserve they just provide a seat number, so that's fine for us. So for reserve we need to provide the least seat, so we can say we can have an appropriate seat for such use case. Stores minimum or least seat number which could be allocated. So life would be super easy when we are having just reserves going on. That means I can just suggest seat 1, then seat 2, seat 3, seat 4, but that's not a case. Once seat 1, seat 2, seat 3, seat 4 is assigned, and post which we can see that seat 2 is unreserved. Next thing, I cannot suggest seat 5. I need to suggest seat 2 over here. So that is one reason that we cannot just rely upon the uh, appropriate seat number. So we need to have one mechanism to know that unreserved seats. So what are the unreserved seats which we are having? So we can say that unreserved seats is a set of priority queue. It is a priority queue. Why priority queue? So that whensoever we are polling this out, any element out, we are certain that the first element is the minimum element. And by default, the priority queue within Java is min heap. So we do not need to worry about any other implementation over here. We can just go ahead and we can say that unreserved seats is equal to new priority queue, and the appropriate seat initially is 1. Why 1? As the counting starts from 1 for seats, and if for any other reason we see that n is less than or equal to 0, as number of seats starts from 1 and there should not be any other seat numbers less than or equal to 0, then this is an invalid case and we need to uh, throw new exception over here. Invalid number of seats. Commenting this out because uncommenting would throw an exception, as we need to add the method signature and adding the method signature would lead to an compiler error. So keeping it as it is. Now here we see that if the unreserved seat is empty, seats, which means our life is very simple and there is no unreserved seat. It means we can just go ahead and iterate, go and suggest the apt seat, as this is incrementally the least numbered seat. Okay, so now we are just return apt seat, and we are having an increment operation as well post which we have returned, so it's a postfix increment. But for some cases, let's suppose we do not have this empty, so we are just going and saying return unreserved seats dot poll. We're polling this out and we are suggesting that take this seat for you, which is obviously minimum. And now we are unreserving, so let's first check whether this function is complete or not. uh, we have unreserved seats complete and this, so there is one case over here. We can add here apt seat is equal to max max number of max seats. That would be a better choice of wordings. So what I'm saying, trying to say over here is, if appropriate seat is equal to max seats, so in no possible way is greater than max seats, then in no possible way we are allowed to have to return this seat. You're getting this point? If the chairs are only 10 and we are saying a guest to sit on a chair number 11, this is not a valid case. So in such case, we are throwing new exception saying seats overflow or seats are less. This would make sense. Seats are less, and for such cases we take ahead a new variable known as int max seats, and we are marking this final so that we don't want to change it in the coming time, and max seats is equal to n. So this is the case for us now. So, and I think this is completed now. Well, now for unreserving method, we see that seat number should be valid. That means seat number should be greater than 0 us, and it should be less than seat max seat, sorry, less than or equal to max seats, then only it is valid. Else, if it is less than or if it is greater than max seats, then it's not a valid case, and we need to throw in such cases an exception. Throw new exception over here, stating that invalid seat number to unreserved. Reserve. Okay, my bad spelling mistakes. Yup, and return null in such case, just to stay consistent with compiler. Anyways, the compiler is consistent even if I didn't throw anything, but still. Uh, Now we are sure that the seat number is fully valid. So we just go ahead and push, offer this to our unreserved seats. Uh, okay, we have unreserved seats completed. We have reserved method completed, and we have constructor completed. Let's run this. Well, it shows the prominent compiler error stating it is null. So null return is not allowed when in case of void. So just return statement. Well, it's accepted as a first test case. Okay, let's check for others as well. Sure, it is accepted solution. Uh, so this was about seat reservation manager. Do let me know down within the comments what are your thoughts upon this explanation. And that was from my side.